Hey everyone, welcome to this video in the Finding Your Next Bug series. This is the very first video in this series, and we're talking about blind cross-site scripting. So Finding Your Next Bug is a follow-on series from Finding Your First Bug. I'm going to assume you watched that video, you understand everything in that video, because what I'm going to talk about is just going to build on that. So I'm going to take a lot of more assumptions about your knowledge. And this will be something that's more kind of suitable for intermediate hackers, maybe people who are beginners who just want to expose themselves to other kinds of bugs. Maybe they want to kind of go deep into like one type of bug and really understand the entire bug before finding their first one. So as before, we looked at cross-site scripting and we really looked at the kind of stored cross-site scripting. I'm going to assume that you've watched this video. And we're going to talk about blind cross-site scripting. So what's the difference? In regular cross-site scripting hunting, we can see whether or not a payload file fires. We can refresh the page, and if we see alert 1, it's fired, right? We don't have to think about where it's firing, we just have to refresh the page. And with blind cross-site scripting, we leave payloads around like Santa leaves presents. But why? We're really hoping they fire on a different page, especially admin pages. So what does that really mean? This is a really complex way of looking at things, but actually when we do regular XSS hunting, we load the page with the XSS payload. We can load it, users can load it. We don't have to worry that somebody else we can see whether or not our payload has worked, basically. With blind XSS, we assume the payload is on some other page we can't see. So logging functionality, administration control panels, even a completely different web app. We don't necessarily know where the payload ends up at the end, but we want to know whether or not it fires because we leave them around all of the time, and then sometimes we can't see them. So wait, what? So a standard XSS, the kind of process of exploitation is try a payload, reload the page, did it work? If not, try another. If yes, report the bug. And this is a really simple one. If we know where the XSS payload is being fired from, we just load up that page, see whether or not it worked. With blind XSS, we actually we prepare our payload and we send it everywhere. We send it to every single endpoint we can see. We hope it will fire some point in the future. We then have a nap, and eventually we get a notification and report the bug. So why hunt for blind XSS? XSS is a really well-known vulnerability. It's one of the ones we teach people first. It's one of the ones that really developers know is a problem. And most bounty hunters look for XSS specifically because it's actually quite easy in terms of time to outcome. So blind XSS has the advantage that the less people are, for example, testing logging functionality, but hopefully someone internally looks at the logs. And this is from the Bugcrowd State of Bug Bounty report. And we can see here that, cross-site scripting reflected, stored, is actually accounts for a large amount. That's nearly like 31% of what bugs are being found. So actually that's such a large portion that if we can kind of change our way of looking by looking for blind rather than looking for like straight up stored, actually we can kind of find stuff. So what type of XSS is it? So there's actually quite a few versions of cross-site scripting. We've got DOM, reflected, generic, stored. Now our payload gets stored on a server via a log file or a database. It's a type of stored XSS. Now what's the main difference between, our blind XSS and the traditional stored one? We just don't know where the payload fires until it fires. We don't know the asset, the URL, the API endpoint, etc. So this is really confusing, Katie. Let's look at a demo. Right, so this is a lovely blog I made. It's very good. I populated it with a bunch of lorem ipsum. And it's written in PHP if you care. So what we have here are comments. So we might put our name in here and do whatever, blah 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 blah. Oh, actually, I've got a lovely cross-site scripting payload in my. There we go. My name is script alert 0. And again, we put it in our comment and we press submit. But it doesn't appear because it's gone for moderation. And we can't see where that might fire now because it's just not here. We might go in here, so let's assume we're an admin now. We go to login, we log in, we go to our approved comments, but actually that payload is being fired in the administration control panel. So we'll go here, and we can see that we have the payload that have run. If we then press approve, and we then go to that particular page, we can see that it might even be filtered on this side. So actually, even if we can get the script to run on one, it might even be filtered here. So that's kind of your standard, what you would expect. You know, you go into your administration control panel, you go to approved comments, and you can see that XSS payload. Now, this is one version of a type of blind XSS. But, okay, you might understand now what the difference between a normal stored XSS and a blind XSS might be. So let's go back to the technical bits. So what's the impact of a blind XSS? As a security risk, it's really the same as a stored XSS. If you want more info on the impact of XSSs, you should go see the first video for more info. But as a technique, it lets us test more parts of an application. We're not just testing one thing where we might actually encounter a web firewall. Actually, there's a ton of admin stuff that happens under the hood of any web or mobile app that we're just not testing for. So where should we look? So this is a lovely tweet that says, that feeling when you get an alert from blind XSS to your hook, but forgot to specify identifiers so you don't know where it was executed. Sad face. So focus on endpoints that have likely admin interaction. You know, requires approval, requires admin approval are all great signs. And again, we're looking at kind of support for products, contact us forms, chat application, support tickets. That's when you're looking at getting that XSS to fire on an employee's web browser. And actually that could be even more dangerous, because if you can get the information of like a cookie of an employee, that's just a lot higher in terms of just risk. And we're looking at error message, anything that might be saved in a log. You know, maybe someone checks that log once a month, but that might be enough to really get some information about, you know, their cookies and stuff like that. Reporting functionality, where a comment on post might be reviewed by a moderator. And blind XSS payloads can often be sprayed to every single endpoint. You should probably avoid doing this because you might forget where you left it, but there are like identifiers and all kinds of things you can see where you sprayed your endpoint and where it was ending up. And you know what? Don't limit yourself. See, Inti here, bug bounty tip. Put a blind XSS payload in your user agent before you fill out a contact form. A lot of like contact forms might recall that because they might want to show what your web browser is, for example. And this is a really great one over here, which is where someone changed their Tesla Tesla name to the XSS Hunter payload. So it may show up on some internal Tesla website, and they forgot about it until their windscreen got a crack, and then it launched, and then it really got some great, like, he got 10 grand I think from that vulnerability. So really don't limit yourself. You're looking at ways that, you know, your XSS might not affect you or regular users, how to affect those employees, how to get on internal managements. Okay, so what do you need to do this? XSS Hunter is very popular, and that's what we'll use in this video. It returns all kinds of interesting stuff like the cookies, a screenshot, the user agent, the DOM, all kinds of stuff. There are other alternatives as well. There's Burp Collaborator can be used to do this. People write their own web services to do this. And even XSS Hunter, you can use the kind of cloud-based one, or you can use it privately. So let's talk about how to use XSS Hunter. Let's do the blind XSS again. So we go open up our web page, and we open up our XSS Hunter. Now we make a website and then we go to make our user and then go to XSS Hunter. And here we can see all the pages we've collected. Now you can see I've only really collected my pages from my local website here. But if we go to the full report, we can see we've got the URL, where it was executed, the IP address, the referrer, the user agent, the cookies, the DOM. We can download the DOM. We've got injection point. We've got a markdown version of what. We've got a lot of information there. But then let's talk about how to actually gather this information. So we'll go to payloads, and you can see here it gives us some of these payloads. But we know that our script is vulnerable to this one. Now, usually we might test more than one payload. We might try, you know, some ways to get past some firewalls, but we'll stick with this. So again, we're going to go to our comments here, scroll down and put in our XSS payload. And you know what, we'll put it in both places. We don't really know where it's firing. And we'll submit it. And again, it's gone for moderation. So as an admin, we come in, we approve comments. And this is our old XSS payload that we can quite safely delete. So let's look here. So I'll refresh the page and we should be able to see that this is now fired again. So it's fired twice because I deleted one of the other comments. And again, here's what we see. We see the whole page. We've got a little screenshot of what the page looks like up here. And we've also got, you know, the cookies, the user agent, whatever. And we have all this information about it. So that's how you use XSS Hunter. And we leave it in different places. So this is an example of leaving it kind of in a comment, kind of standard XSS location really. What about login functionality? So we have on our little web page here, where I log out, we have an email address and a password. Now, what some web apps will do is they'll work out when you've used a wrong password. So we do half the password, try and log in. The credentials do not match our records. Now, what if we change the email address to our blind XSS payload? And again, we get an error saying, what does it say, not a valid email, I think it does. And we might try and make it as valid as possible. Maybe we add, like, you know, an @ symbol here and try and bypass this. I'm pretty sure that says it's not right. But maybe that never works. We just put in whatever, and we might change the password to be one. And again, we log in, it hasn't worked. I was like, okay. But what's actually happening when we then see our admin account here? And we go here, we go to admin, and we go to view logs. And actually, we can see what someone's logged in as. And we can say, okay, incorrect login with account. Oh, what's that? You know, we're looking at kind of this one here. So someone's tried to log into an account with a weird password. So we go to XSS Hunter and we refresh the page here. And we can see that that log has now hit our XSS Hunter. And we can see the screenshot and we can see, you know, the full report of what's happened. So actually, if we limited ourselves, maybe the comments wouldn't necessarily be vulnerable, but actually the report would be. The reporting for the logging would be. Oh, I've done something wrong here. So that's kind of the end of the technical explanation. I hope that really helps you learn how to use XSS Hunter. Let's have a look at some real reports and see what people are able to do with this. So this is a really simple one. The admin dashboard has an XSS, logs in, and then goes to some kind of specific function, intercept the post data with some server IP. This person's created their own custom kind of XSS Hunter, if you like. And then what they were able to do is they targeted some URL which is linked to the admin dashboard, stealing a cookie from an admin user. So same as XSS Hunter where it shows us all the cookies, this is what their one has also done. And that really shows, you know, our cookie, and again admin dashboard. Same one, another Zomato bug. This hacker targeted a report feature as they knew it would be viewed by an admin. You know, reports. Maybe this one is reporting a review, because they would have a report review for something that's maybe inflammatory or untrue. And then they put the blind XSS payload in the report. It doesn't really use XSS Hunter. It uses a custom XSS Hunter, but it's the standard kind of same concept, and it creates you a standard XSS. You know, it just appears somewhere different. And again, we're seeing the cookie come back and what actually the kind of user review it, what the admin will see, and it even includes a screenshot here, which is great. Blind stored XSS on parcel.grab.com name parameter. So very simple blind XSS. This hacker changed their name to a blind XSS payload. We can imagine it was using something like XSS Hunter, creates a new account with the name, and when the admins can see all the users of our application and see it then fires. Now this is interesting because there's more impact here. Because of the page it fires on, with the user email addresses, the attacker can also take a screenshot or take all the data just like XSS Hunter can, and then take all of those user email addresses. So it's really upping that impact, especially with understanding the business side of things. And the impact is the ability to download personal info about the drivers on this platform, because he shows more here, more information, sensitive details, what they were able to do, showing what exactly was visible and stuff like that, and a lot of screenshots, which is really great. IMP, blind XSS, and admin panel for reviewing comments. Finally, we get someone confirmed to use XSS Hunter. We can tell because if you look here, it's xss.ht, so it means it's XSS Hunter. So this hacker targeted a feedback form, injected their XSS Hunter payload, and it worked. You know, sometimes blind XSS can be as simple as that. And Rockstar actually reports some extra impact due to the type of CMS it used. Especially if you look here, you know, we have same as the stored XSS, but actually it was written in AngularJS, so it may be possible to exploit an RCE via the XSS. So actually we have, so we don't necessarily know, but because we've got that blind XSS, we know what it's running. So this is a really great example of not just getting a blind XSS, but actually being able to get that larger impact from that blind XSS. Blind stored XSS against, oh my god, I'm not going to be able to pronounce that, Lahitapolia, so employee, session information leaking. Another fairly simple blind XSS, but a great example of how it can do some real damage when targeted at administrators and employees. This one allowed for exfiltration of employee data. So very simple. In this case, it was a malicious file that had the payload in it, the SVG file. Now, as they're using Internet Explorer, the IE will sniff the MIME type from the file and open it as SVG instead of plain text, and will trigger the XSS. And actually what they showed was this kind of getting the employees' cookies out, really showing how you could exfiltrate data. And in fact, the full report has even more information on how that was then used even more. So this is the final one here, which is cracking my windshield and earning $10,000 on the Tesla bug bounty program. And I really want to encourage you to read it for yourself, so I'm not going to fully explain it. But in summary, Sam had set his payload's name to a blind XSS payload. When his windscreen was cracked by a stone, he asked Tesla for a repair, and his payload fired. And actually, the screenshot he got had some really juicy info about his car, like a lot of kind of diagnostic information. And he couldn't access that page directly, but the fact that he could do it via his car meant that, you know, at the moment he was just doing a kind of diagnostic, if you like, XSS where it just replies data back. But actually, if he had done something malicious there, he could continually kind of understand how the page worked, how he could get data out, if he could access someone else's data, and Tesla did a full kind of look at this, and he got 10k thanks to a rock. So I'd really recommend reading this, because it's really interesting to show how this impact can actually be even higher. And before I go, I want to share some funny stories about blind XSS, something a bit fun. You know you're a bug bounty hunter when you receive XSS payloads in the mail. So here they've got a blind XSS payload as their name. When you're on Netflix and you receive alert from XSS Hunter because of a payload you submitted 2 months ago, bug bounty XSS is timeless. So just because you submitted it 2 months ago doesn't mean it won't fire now. Setting my device name as a blind XSS payload, you wouldn't believe the crazy stuff it had fired in. DEF CON tomorrow should be fun. I refresh my XSS Hunter account about 10 times more often than I actually test for blind XSS. It's like opening the refrigerator when you know there's no food inside. Pro tip, distract other researchers who are using XSS Hunter by making fake payloads fire on made-up admin panels. If you know someone's XSS Hunter payload, you can just create your own fake admin payloads and then place their one in to confuse them. Lamal. So about 2 years ago, I uploaded a file to VK, a Russian social network, and named it as a blind XSS payload. Just now I get an email from XSS Hunter telling me my payload was triggered on a third-party search engine for files uploaded to VK. Fuck's sake. And that was November 2019, and it happened again in January 2020. So I wanted to share those kind of funny stories of kind of XSS Hunter. I was doing some research for the video, and I thought those were pretty funny. So I hope you've enjoyed this video. You'll notice that this is a little bit more technically complex than the first bug series was. Let me know what you think. Did you like the content, the kind of pacing of it? Was it still interesting to you? And I will see you all in the next video.